You ever stop to think about what happens in that split second after you've hit play on a video or tap order now on some food? Well, you're actually tapping into this hidden world, a really powerful engine that runs pretty much everything you do online. And I mean, it's not just you. Just try to imagine the absolutely colossal amount of information that services like Amazon, Google, and Facebook generate every single second. We are talking about a whole universe of data, this endless, nonstop stream of clicks and likes and transactions. You'd think it would be total chaos, right? A complete digital mess. But it's not. Your order shows up, the right video actually plays, your feed updates like magic. So, what is the secret here? How is all of this managed with such incredible pinpoint precision? To really get the solution, first we have to go back and look at the problem. See, before we had our modern systems, just managing data was a huge, huge headache. And the way we used to do it, well, let's just say it was completely broken. It was called the flat file system. And to give you an idea, imagine trying to manage a billion contacts by keeping every single one in a separate text file. The problems were massive. You had data getting duplicated all over the place, which of course led to tons of inconsistencies. If you changed a phone number in one file, but you forgot about another one, suddenly you've got conflicting info. It was slow, it wasn't secure, and it just could not handle the world we live in today. And so, to fix all that chaos, a hero emerges, a master organizer that totally changed the game for how we handle information. It's called the Database Management System, or as you'll usually hear it, DBMS. So what is a DBMS? Basically, it's the software that sits right in the middle, between you, the user, and the actual database where all the information is stored. It's the brain of the whole operation, and it was designed specifically to fix all those problems from the old file system. This is probably the best way to picture it. A DBMS is like a master librarian. You don't need to know where every single book is physically located in some gigantic infinite library. You just go up to the librarian and ask. They find it for you, they can update it, put it back, all while making sure the entire library stays perfectly organized. It's pretty amazing. So, how in the world does the DBMS pull off this magic trick? Well, it uses this really clever three-level architecture to hide all the complicated stuff. You, the user, you're at the top, the external level. You just see the app on your phone. Underneath that is the conceptual level, which is like the blueprint for how the data is structured. And way down at the bottom is the physical level. That's the real nitty-gritty of how bits and bytes are actually stored on a hard drive. The beauty of it is, you never have to think about those bottom two levels. Ever. All right, so the DBMS is our super librarian, but what's the organizational system it's using? What's the actual blueprint for turning all that messy, chaotic data into a perfectly organized library? It all goes back to something called the relational model. This was a brilliant idea from a guy named Dr. E.F. Codd way back in 1970. And his proposal was just so elegantly simple. Organize everything into tables. Yeah, just tables. Kind of like a spreadsheet, but with a bunch of really powerful rules. These tables are also more formally known as relations. At its heart, the whole idea is simple. Just take a look at this table of student information. It's clean, it's intuitive, you get it right away. Each row is a different student, and each column is one piece of information about them. Now, in the world of databases, they have a fancy name for a single row. It's called a record, or sometimes you'll hear the term tuple. All it means is one complete entry. So in this case, it's everything we know about Sunil. And a single column, like name or age, well, that's called an attribute. It's just a specific characteristic of each record. So really, a table is just a collection of records and their attributes. It's a remarkably clean and simple way to organize a ton of data. Okay, but here's the thing. For these simple-looking tables to run basically the entire internet, they need some really strict, unbreakable rules. These rules make sure all the data stays accurate and connected. And they're called keys. The most important one, the big boss, is the primary key. A primary key is one column that guarantees that every single row is one of a kind. Think of it just like your social security number or a student ID. You could have two students named Sunil, for sure, but they will always have a different student ID. A primary key can never, ever be empty, and it can never be duplicated. So right here in our students table, the student ID is our primary key. It's what uniquely identifies Sunil, Anil, and Rahul. So far, so good. But what happens when we want to know which courses these students are taking? For that, we're going to need another table. And here it is, our enrolled courses table. Now notice it also has a student ID column. We can see that student 101, who we know is Sunil from the other table, is enrolled in 2 different courses. See that? That student ID column is the bridge that connects our 2 tables together.
And that little bridge, that connection, well, that has a name too, the foreign key. A foreign key in one table points right back to the primary key in another table. And this right here is the fundamental concept that creates relationships. It's how we can link all these different pieces of data together cleanly and super efficiently. You know, this whole process of carefully designing our tables to avoid repeating ourselves, like separating student info from course info, that has a name. It's called normalization, and it's really the art of building a clean, well-structured database. It's what makes sure that if a student changes their name, you only have to update it in one single place, which prevents all kinds of errors later on. Okay, let's put this all together. We've got our master librarian, the DBMS, and it's using this really organized system of tables all connected by keys. So how does this all come together to power the apps and services we literally use every single day? Well, the secret ingredient is something called data independence. Remember that 3-level architecture we talked about? Data independence means that developers can completely change how data is physically stored. They can add new hard drives, change file structures, whatever, without breaking the app that you see on your end. This is exactly why a service like Facebook can push out updates all the time without the whole thing just crashing on you. So, the next time you stream a movie or book a flight or just check your bank balance, take a second to remember this invisible architecture that's humming along behind the scenes. This whole elegant system of databases and tables and keys, it's the silent, super reliable foundation of your entire digital life. You know, we've come a long way, from messy files to these elegant tables. But the amount of data we're creating today is just staggering, on a scale Dr. Cod probably could have never imagined. Which leaves us with one final, really interesting question. As our digital universe just keeps expanding exponentially, what brilliant new idea is going to be the next step? What comes after the table?